Welcome to a video where I will show Anritsu 5G SmartStudio NR functional test solution for end-to-end IP data throughput test. My name is Martin Marga and I'm Anritsu Field Application Engineer. One of the focus of 5G technology is enhanced mobile broadband, which brings very high data throughput speeds. With very high data throughput speeds, it's essential to test mobile devices, whether they are able to process data, also in a maximum achievable throughput rate, for which mobile device needs to have enough computing power. To do such tests, we can do end-to-end IP data throughput test. Our test setup on top of MT8000 and MD8475B instruments also contains server PC, which will be generating IP data stream in downlink. Server PC is connected to data test module of MT8000A with an optical cable. There is also Ethernet cable connected from the data test module directly to MD8475B, where the user plane data is split and sent to MD8475B for LTE network. IP data stream path is going from the server PC to data test module where it is split. One part goes to MD8475B for LTE cell, and then all the data is then delivered from the LTE cell and 5G NR cell directly to the mobile device. IP data throughput in this case is generated by the application called iPerf, where in the server PC it serves as a client, and the same application is installed in our smartphone, which in this case serves as a server. In this case, test of IP data throughput is done in non-standalone architecture of 5G deployment as an option 3x. In this option, user plane data is split in secondary cell group of EUTRA new radio dual connectivity. SmartStudio is already launched and simulation is running, where we have one LTE cell and one 5G NR cell. LTE cell is in band 1 with 20 MHz bandwidth, 2x2 MIMO in downlink in transmission mode 4, 256 QAM modulation in downlink and 64 QAM modulation in uplink. And we use static scheduling with a full allocation of the resources for the best effort, which means to achieve maximum throughput speed. 5G NR cell is in band N78 with 30 kHz subcarrier spacing, 100 MHz bandwidth, 4 antennas in downlink, meaning 4x4 MIMO, and 256 QAM modulation in downlink modulation. And we use static scheduling with maximum number of resource blocks. Such cell configuration gives us approximate rate of 194 Mbps for LTE and approximately 1.2 gigabit per second in downlink for 5G NR cell. This Windows is SSH session to our server PC, and this window is our screen of our smartphone serving as a mobile device. If I open throughput monitor, I can see how much data speed we have right now for at the MAC layer for the LTE cell and for the 5G NR cell. Before I start IP data throughput stream, I will verify the connectivity with ping. So the IP data connectivity is okay. I will start terminal in smartphone, where I will start iperf as a server, so the server is now listening, and I can start IP data throughput stream from the server PC with iperf. And now the IP data stream is slowly ramping up to the maximum possible value. So if we look at the report, we can see that the maximum achievable throughput was about 1.37 gigabit per second. In which case, as an average, we received as average bit rate was 1.14 gigabit per second, and in 10-second time, we transferred 1.33 gigabytes. Now you know how easy it is to test end-to-end IP data throughput with Anritsu 5G SmartStudio NR functional test solution. Thank you.